Hi all again. So this question doesn't really need to be too mathematical, so I guess it's just to give you an idea with some relationships that can be used. So I think in the exam you can take in a book that's got I think it's just some an annuity values sort of thing. Like it'll say A5 with an interest rate of 5%, A10 with an interest rate of 5%, and so on, just pages and pages of that, as well as different distributions in there, probability distributions that is, and so on. So I guess that's just to give you an idea that way during the exam you won't need to calculate something like this if you're given a question like that. So by knowing this relationship, we may be able to answer this question very, very easily instead of trying to use, you won't even need a calculator then. Okay, so let's look at part A. It says suppose m and n are positive integers, show that. So annuity m plus n is the same as am and then an discounted back m years. So if we look at it on a timeline, we just start off over here and go like that. Let's just, for whatever, assume that m is bigger than n. Doesn't matter, there can be any size. Start off at time 0 and then we go to time m. Now it's saying that here we have this annuity being paid over m amount of time, and you're going to get your payment whenever. And then our next one is saying that we'll have an annuity going over the period n. Sorry, I shouldn't write that. I should write it like more like this. That this period over here goes for m years, periods, whatever, and this amount of time is n, value of n. And so if we want to know what is the present value of all of this money inside of here, all of these payments, well, we'll first find the present value, which will bring it back to this date, and then we'll discount that back all the way to the present value times 0, which is where we started. Okay, so that would all go over there. So what do we have when we have all that? Well, we've got this present value over here, m, so we know what all of these payments are worth, and then we also know what all of these payments are worth brought back to time 0 as well. So at time 0, we know what all of this is. Okay, now you say, well, why can't we just calculate all of that? Well, we'll see in a moment. So now, all of that is going to become am plus n, whereas this is just am, and this is just an, but it's deferred for m years. So if we only have in our book, if we only have something that says, the annuity for m periods, which could be, say, 100 periods going ahead, and n is then 20 periods going ahead. So then if we wanted to know what the full 120 periods going up are, well, then we can actually just find what 100 is plus the deferred value for the next 20. So let's just see an example for that, if that didn't really make sense. So we look at B. It says a loan of £10,000 is repaid by constant monthly payments, monthly in arrears for 10 years. The interest rate is 1% per month effective. Okay, so since we're talking about months and we have a monthly effective, we don't need to find out any annual amounts. Find what the monthly payment is. So we're going to say that the present value of the loan of £10,000 is equal to, and if it's going for 10 years, 10 times 12 months is then 120 periods. So some monthly figure multiplied by some annuity, and it's in arrears, so it's a regular annuity or an immediate annuity. There's no payment amount over here. In fact, we're just going to say it's going to go over 120 periods, because it'll be n. Okay, because we just have our interest rate of an effective 1% per month. So that's really what we're going to work out. Now, if our book doesn't tell us, and we don't have a calculator, what 120 periods are, then if it only goes up to 100, then what we can do is say that this equals C, and we're going to have A of 100 plus deferred amount V will be 100 up here times A the 20, like that. Now we might have this written in the book, we might have that written in the book, and I mean, you still may have a calculator with you. I'm not sure if the book would have something like this written down. Probably, I'm not sure. I actually haven't looked into that much depth, and that still equals 10,000. And so then what we have is we'll just have that C is going to equal, of course, 10,000 divided by A, the 100, plus discounting 100 periods, A to the 20. Okay, and this is where, over here, V is going to equal 1 over 1 plus I, which is 0.01. And that's really it without trying to calculate anything. That's just a way to see the reasoning behind something like this, knowing the relationship there. Maybe even in the question they might say V to the M is whatever, A to the N is this. Figure something out, and you just have to know off the top of your head that this relationship works and it holds, and you can just see visually there that it does work. Thanks for watching.